All right, guys, we're going to talk about lesson 7 today. This should be the last time, Bravos, that we have to do a remote lesson online. 7.1 asks us, without computing, without doing the math here, is the solution to this positive or negative? How do you know? Try to figure that out. Which of the following are solutions to this? So as we start to solve this, what are we doing to make this better? We're trying to isolate that x, right? This says x plus negative 2.7. If I read it kind of inside out, x plus negative 2.7 gives me negative 3.5. Well, let's see what that means. That means that I'm taking this unknown value and I'm adding negative 3.5 to it. Well, how could I undo that negative, sorry, I'm adding negative 2.7 to it. How could I get rid of this? I want to try to isolate that x. How can I get rid of a minus 2.7? Well, the answer is if I add 2.7. But with an equation, here's the thing, it's like a scale. It's like a balanced scale. And if I add 2.7 to this side, I also need to add 2.7 to this side to keep that balanced. The equal sign, the most important symbol we have in mathematics. It means that the left-hand side of that equation is exactly the same as the right-hand side of that equation. And in order to keep it balanced, we need to do the same thing on both sides. So if I'm going to add 2.7 to both sides, the question is which of those represent the same as solving for x here. Okay, so think that through. Now we're going to do activity 7.2. We're talking about phone inventory. A store tracks the number of cell phones it has in stock and how many phones it sells. This table shows the inventory for one phone model at the beginning of each day last week. The inventory changes when they sell phones or they get shipments of phones into the store. So on Monday they had 18 phones. The change was minus 2. And on Tuesday they resulted in 16 phones. After Tuesday, the change was minus 5. They resulted in 11 phones. Then a change of minus 7 resulted in 4 phones. A change of minus 6 resulted in minus 2 phones, negative 2 phones. And then they have this big change of 20. Now, we've talked about this before. There's not a positive sign in front of the 20. If it doesn't say positive or negative, we all assume it's a positive. So maybe what this means is that every Friday the store gets a shipment of new phones. So that's kind of the day that things balance off. All right, I want you to answer question 1. What do you think it means when the change is positive or negative? Question 2, what do you think it means when the inventory is positive or negative? So answer those 2 questions. And then based on that information in the table, what do you think the inventory will be on the end of Saturday morning? So the last table ended up with Friday morning, and then that change on Friday, what do you think the inventory will be at the end of Saturday or on Saturday morning? Explain your reasoning. What's the difference between the greatest inventory and the least inventory? So you've got the highest amount of phones they have, the lowest amount of phones they have. The difference means how far is it between those 2 numbers? We are going to skip 7.3 because the directions here are more complicated, I think, than they need to be. So we're going to skip 7.3. You can skip over that one. Pause, make sure you've answered everything up to this point. And then in 7.4, here's where things get a little more interesting. Have you seen this coordinate grid before? I don't know that we've talked about it much. Maybe you did in 6th grade, maybe you did in 5th grade, but important, really important stuff coming up here. As we look at the coordinate plane, this is called the coordinate plane, we notice a few things. First of all, we have 2 lines crossing each other, and that's where the numbers are. Sometimes we write the numbers there, sometimes we don't. If we don't, we're assuming we're counting by ones. We notice the y values go up and down. This is called the y-axis. A-X-I-S, not axis, but axis. We have other numbers going this direction. That's called the x-axis. And there's a little x there, and there's a little y there. That point at the middle, that's the coordinate point 0, 0. And that point has a name. It's called the origin. It's kind of the beginning, the starting point, the main place we start. Okay? Now the question's asking us to plot these points on the coordinate grid. When we plot points, we go x, comma, y. We go in the left-right direction first, then we go in the up-down direction. Always, 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 everybody does it this way. Everyone in math knows that's what we're graphing. Okay? So if we're graphing point A as 5, comma 4, that means we're going to start at the origin. So I'm going to start at 0, 0. I'm going to go 5 in the x direction. So 1, 2, 3, 4, 5. And then from there, I'm going to go 4 in the y direction. 1, 2, 3, 4. And this is the point at 5, comma 4. And I'm going to label that point A. Now I'm going to do the next point. Next point says B is 5, negative 2. So over 1, 2, 3, 4, 5. Again, starting at the origin. I'm going to go over 5. This is the positive direction, positive x direction. This is the negative x direction. This is the positive y direction. This is the negative y direction. So for that 5, negative 2, I'm going to go positive 5 in the x direction, negative 2 in the y direction. That puts me right here at point B. And I'm going to label these as I go. 5, negative 2. This was 5, 4. I never want to do that, but then at the end I'm like, I should have labeled them to begin with. All right, point C. Point C is at negative 3, negative 2. So again, I go back to the origin. I go 1, 2, 3 in the negative x direction, so that's back this way. And then negative 2 in the y direction. There's my point. Point C, negative 3, negative 2. And then my last point is point D, which is at 3, 5. Oh, sorry, not even close. Negative 3, 4. Negative 3 in the x direction, 1, 2, 3, 4 in the y direction. That's my point D, negative 3, 4. Okay? Now the questions start to read like this. What shape is it if you connect the dot? What shape is made if you connect the dots in order? Well, if we go A, B, C, D, what shape do we get? From A to B, B to C, C to D, and then D back to A. What shape is that? What are the side lengths of figure ABCD? How long is it? How far is it from one side to another? How far is this side? How long is this side? How long is this side? How long is this side? And we can get those by counting units. We can also do that by subtraction. Question 3 says, what's the difference between the x-coordinates of B and C? Well, the x-coordinate of B is negative 3. The x-coordinate of C is 5. The distance between those is 1, 2, 3, 1, 2, 3, 4, 5 would be 8 units. That comes from the absolute value, remember we talked about that, of negative 3 minus 5. Or the absolute value of 5 minus negative 3. How far between them? It's 8 units. So that absolute value symbol comes into play here. What's the difference between the x-coordinates of C and B? We just did that one, sorry. How did the differences of the coordinates relate to the distances between the points? So we think about that. We think of subtraction here. So lots of important stuff coming in this lesson, this coordinate plane. Really the first time we've run into this coordinate plane. And as we read through our lesson summary here, lesson 7 summary, sometimes we use positive and negative numbers to represent quantities in context. Some contexts we've studied include temperature, elevation, inventory, and account balance. Electricity flowing in and out, that was that solar panel, the one we kind of skipped. In these situations, using positive and negative numbers and operations on positives and negatives help us understand and analyze them. To solve problems in these situations, we have to understand what it means to when the quantity is positive, when it's negative, what it means to add and subtract them. Then we're going into the 2 points on the coordinate plane. When they're in a horizontal line, we can find the distance between them by subtracting their x-coordinates. So the distance from here to here would be -5 minus -2. Or if I count them out, I would be going 1, 2, 3 units. When the 2 points and the coordinate plane lie in a horizontal line, you can find the distance between... Ooh, they made a mistake here. This should say a vertical line. You can find the distance between them by subtracting their y coordinates. How far from -5, 3 to -5, -4? Well, let's see. In the y direction, 1, 2, 3. 1, 2, 3, 4. There's 7 units that way. And remember that subtraction. Subtraction is the distance. The distance between two numbers is independent of the order. That means it doesn't matter positive or negative. The difference does depend on the order that we add or subtract in. And that's it. You're going to jump over and do some of the practice problems in your book. And we are done, guys. That's it. Good job, bravos. We've made it this far. We'll finish strong this year.